Hello guys, my name is Baha. I welcome you to BajaRC.me, the first real-time FPV remote control platform where you can take control of my RC cars. In today's video, we're going to be reviewing Caddx Ascent VRX VTX systems. I'll be sharing best practices on installing a VTX system on RC car. Also, we'll be sharing you the settings that I use for best video quality and low latency. If you haven't checked out my last video on unboxing and thoughts on Caddx, you can check out here. Let's talk about installing VTX on RC car. Installing VTX on RC car is different from drones. On drones, you usually use flight controller. However, I'm not going to be using flight controller on my RC setup. Flight controller needed to handle the power and OSD. I'll be powering my VTX directly through battery. For VTX input voltage, it should be anywhere from 3 volts to 12 volt. Basically, it's 1S to 3S batteries. Please do not use higher voltage batteries as you may damage the system unless you're using back step down converter. Since RC cars don't have props airflow like drones do, you're risking to damage your system by overheating it. I recommend installing an external fan. For my setup, I'll be running a 3S battery with 800 milliamps and 2-pin JST cable. Also, I have a 12 volt fan that has the 2 pins. Make sure the fan matches your power source, otherwise you can damage the fan or cause the shortage and even a fire. Always handle your LiPo batteries safely. Let's talk about wiring setup. I cut the positive and negative wires from JST 1.0 4-pin cable on VTX. I'm using only positive and negative wires. I meshed them with a fan wire and soldered to JST 2-pin female cable. For the VRX, I power it using a 12 volt 2 amps adapter. Before powering anything, I recommend updating the firmware on both VRX and VTX system. This will unlock the 100 FPS and channel hopping. If you don't know how to do it, I will leave the link in description. Let's dive into VRX menu overview. As you can see, VRX has 3 main tabs: channel, settings, and playback. The channel tab got 7 channels plus CHP. CHP is a boot up channel used for linking. It's not recommended for actual driving because it's crowded and prone to interference. After linking, switch to channel 1 through channel 7. Also, you can find the channel hopping at the same page. Now let's go to settings and camera settings. On the camera settings, you can find the scene, EV, saturation, sharpness, contrast, WB, rotate, and ratio with the 3D DNR. On the scene tab, you can change from standard to racing mode. Let's move to EV. EV stands for exposure value. This will allow you to change exposure. Tabs saturation, sharpness, and contrast are straightforward. WB stands for white balance. Moving to 3D DNR. 3D DNR stands for digital noise reduction. It's advanced noise reduction feature that cleans up grainy or noisy video in FPV feed, especially in low light, indoor, and high ISO conditions. Let's go back to settings, display, and debug. You can turn on and turn off the settings to show the red text on the screen. That information can be useful if you're trying to set up your system. Let's move to focus mode. Focus mode prioritizes the center of the screen when signal gets weak. Instead of whole screen breaking up evenly, the edges blur first while the center stays clear longer. I'm not gonna go in detail for each setup device, but here's the video of every settings that is inside On transmitter power, you can change from 100 milliwatt to 25 milliwatt. That will determine the strength of the transmitter on VTX. Resolution can be changed from 720 to 1080 pixels. Bandwidth can be changed from 5 to 25 megabit per second. The bigger bandwidth results in better quality but slower latency. The lower bandwidth results in bad quality but better latency. Frame rate can be changed from 100 FPS to 30 FPS. Standby reduces transmission power when disarmed. Since RC cars don't use flight controllers to trigger arming signals, you may want to disable standby to prevent low power issues. Everything else should be straightforward. Now, for best quality and low latency, I would recommend setting up resolution to 720, frame rate to 100 FPS. On a scene, select race or standard for smoothness. For bitrate or bandwidth, you should select standard or low, which is 5 to 15 megabit per second. Make sure your channel hopping is on. Focus mode is auto. Having 720 to 100 FPS gives you around 33 millisecond latency and feels very responsive. 180 pixels looks slightly sharper but increases delay. For RC cars, low latency is more important than extra sharp. Overall, I'm very pleased and very satisfied with the video quality and responsiveness of the system. For the RC application, I think Ascent Systems performs very well if you properly configure and cool it. In my next video, I'll be putting it in real-world testing. And if you enjoyed this video, please consider subscribing and joining my Discord channel. I'll see you in the next one.